Venus, the second planet from the Sun, is often referred to as Earth's sister planet due to its similar size and composition. However, its surface is hot enough to melt lead, with temperatures reaching up to 864 degrees Fahrenheit 462 degrees Celsius. Despite this, there have been proposals to colonize Venus. One idea is to build floating cities in the planet's upper atmosphere, where temperatures and atmospheric pressure are more tolerable for human habitation. The atmosphere of Venus is mostly carbon dioxide, but there are also traces of sulfuric acid and other toxic gases. However, it is believed that these can be filtered out using advanced technology. The proposed floating cities would consist of airships that would float around the planet using the wind currents in the Venusian atmosphere. These airships could be powered by solar energy, which is abundant in the upper atmosphere of Venus, and could also use the acidic clouds of Venus to generate electricity.
They are created by the collapse of massive stars and have such strong gravitational fields that nothing, not even light, can escape once it crosses the event horizon. At the heart of every black hole is a singularity, a point of infinite density and zero volume, where the laws of physics as we know them break down. Around the singularity is the event horizon, which is the point of no return, beyond which anything that enters will be pulled in and crushed into the singularity. Black holes come in different sizes, from small ones that are a few times the mass of the Sun to supermassive ones that can have the mass of billions of suns. They are also believed to play a crucial role in the formation of galaxies, as their gravity can influence the motion of stars and gas around them. Despite their mysterious nature, scientists have been able to study black holes through their effects on nearby matter. For example, as matter falls into a black hole, it heats up and emits radiation that
The internet has revolutionized the way we live our lives, from how we communicate to how we work, shop, and entertain ourselves. But how does the internet actually work? In this episode of Science Under 60 Seconds, we explore the science behind this incredible technology. At its core, the internet is a network of computers and servers that are connected together through a system of routers and switches. This allows information to be sent from one device to another, regardless of where they are located in the world. The Internet uses a set of protocols, known as the Internet Protocol, IP, to transmit data between devices. When you type a website address into your web browser, the browser sends a request to the website server using the IP protocol. The server then sends the requested information back to the browser, again using the IP protocol. Another important technology used by the Internet is the Domain Name System, DNS. This system translates human-readable website addresses into the IP addresses that are used by computers to connect to the Internet. Without DNS, it would be much harder to remember and access websites using their IP addresses.
Dark matter is a mysterious substance that makes up about 85% of the matter in the universe. It doesn't emit, absorb, or reflect any electromagnetic radiation, which makes it invisible to telescopes and other instruments. So, how do we know it's there? Scientists have been studying the effects of gravity in the universe, and they have noticed that there is more gravity than can be accounted for by the matter we can see. This led to the hypothesis that there must be some form of invisible matter that is causing this gravitational effect, and this is where the idea of dark matter came from. Dark matter is believed to be made up of subatomic particles that don't interact with light or any other form of electromagnetic radiation. This means that they are completely invisible to us, and can only be detected through their gravitational effects. Despite years of research, scientists still don't know exactly what dark matter is made of, but one popular theory is that it is made up of weakly interacting massive particles, WIMPs. Understanding dark matter is crucial for understanding the universe. While it may be invisible to us,
touchscreens are ubiquitous in our modern world, but have you ever wondered how they work? They use a combination of technologies to detect and respond to touch. The most common type of touchscreen is called a capacitive touchscreen, which consists of a transparent conductive layer, typically made of indium tin oxide, (ITO), overlaid on top of a glass panel. When you touch the screen, your finger creates an electrical charge that interacts with the conductive layer, causing a voltage drop. The touch controller reads the changes in the voltage and calculates the location of the touch. This is why capacitive touchscreens require a conductive material, such as your finger, to work. Capacitive touchscreens are more responsive and accurate than other types, which is why they are so popular in smartphones and tablets. Another type of touchscreen is a resistive touchscreen, which consists of two thin layers of conductive material separated by an insulating layer. When you touch the screen, the layers make contact at the point of touch, creating a voltage drop that is detected by the touch controller. Resistive touchscreens are less expensive than capacitive ones, but they are less responsive and less accurate.